All right, so I'm going to show you now the formal proof of convergence. What is strange to me looking at this now is I never forgot that when we were taught, at least how I was taught the formal proof of convergence, they told us the definition and then the professor just gave example after example of proofs. And it seems very strange now. So I'm going to show you the steps of how to arrive at the proof and ask you to write the clean proof. So I'm going to show you how to write the clean proof as well. The first step is to make a guess at what the limit should be. Now we already graphed this earlier. I can see it, and it looks like the limit should be 10. So I'm going to make a guess that my x in this case is 10. So this is scratch work in step 2 that's not turned in. This is work that's done at your desk. Depending on who you have for the real analysis professor, they might not appreciate seeing your scratch work. In our notebooks, we will have the scratch work. I need to see your scratch work, so make sure that that's provided so that we can see where you went, what your thought process was, because not everybody's capital N's has to be the same. So what we'll do for scratch work is we'll go from the last line of the formal proof. The last line of the formal proof is that xn minus x has to be less than epsilon for any arbitrary epsilon. So I'm going to keep epsilon as a variable and not put in a number for epsilon. And I'm going to try to find the capital N. That is because in the definition, there's a part of that definition that says there exists a capital N. Whenever I have to prove there exists, I have to actually produce that capital N. So I'm going to find capital N by solving for little n in this inequality. So scratch work doesn't need any explanation. So this is my scratch work. It's never going to be seen by anybody but everybody who looks at YouTube. But I'm just going to combine these two fractions using getting a common denominator, and then I get 3 over n is less than epsilon, and I expand that as an inequality. But 3 over n is always positive, so I can drop this last part of the inequality. So I don't really need that last part. I'm just going to work with this part here. If I flip both sides, I get n over 3 is bigger than 1 over epsilon, and I get that little n has to be bigger than 3 over epsilon. This is almost weird when you see it backwards, but I'm going to show it to you forwards and it's going to make sense. That's going to be my capital N. Capital N is going to be the first integer, positive integer, that's bigger than 3 over epsilon. We're going to test this in class using Excel, but this gives me a formula of where to set that cut point, whatever epsilon someone gives me. Now, if epsilon is 0.01, I don't have to drag everything down. I know that my capital N is set to be 3 divided by 0.01. So that tells me where to set it. All right, how does the proof look like? What did I see? What did my professors give me? They only gave me step 3. I had no idea where everything came from. So you start out these proofs always with let epsilon greater than 0 be given. I put the word arbitrarily just to emphasize the fact that epsilon is a real number that's arbitrary. I'm going to select capital N so that capital N is bigger than 3 over epsilon. If you're wondering where that 3 over epsilon came from and you ignore me on step 2, well, if you just saw this proof, you would think that it came from left field. But it didn't. It came from our scratch work. So that didn't come from left field, but it did appear to me as a student that it came from left field because I was wondering where he got 3 over epsilon. And he will be unnamed for now. He also happened to be my sister's honors calculus teacher, and she dropped math as a major. So this was frightening just to see this 3 over epsilon just show up out of nowhere. But we know from step 2 where it came from. I claim that 10 is going to be the limit of this sequence. So xn minus x is this guy, which by combining fractions, I know this becomes minus 3 over n, which minus 3 drops out, I get 3 over n. Now 3 over n is less than 3 over capital N because my little n was supposed to be bigger than my capital N. And if little n is bigger than capital N, then 1 over n is less than 1 over n. Flipping fractions makes the inequality turn around. Where did that little n is bigger than capital N? Well, I said that. Let little n be bigger than capital N. So that's where I get that. So I'm using that inequality. But capital N was supposed to be bigger than 3 over epsilon under my left field assumption, which means that 3 over capital N is less than epsilon by cross multiplying. So xn minus x is equal to 3 over n, which is less than 3 over capital N, which is less than epsilon. So what you've shown is that given any arbitrary epsilon, there exists a capital N. Specifically, I found it for you. It's the first natural number bigger than 3 over epsilon, such that as little n's are bigger than that capital N, xn minus x is going to be less than epsilon. That's the definition of convergence. So by definition of convergence, the limit of my sequence is equal to my selection of x.